You're listening to the Chronicles-of-Livin-podcast, where we talk to everyday people about everyday things in the past, present, and future. Now let's talk. Greetings, my visionary dreamers. How is everybody doing on Let's Talk Sundays? For those of y'all who are just tuning in for the first time, this is Adionne, your dream pusher, your lifeguard, saving you from the world, saving you from yourself. Get out your own way and do the damn thing. And today, I have an awesome show for you guys. I have my special guest, ira-pastor, and he is the Chief Executive Officer for BioQuirk, Inc., over 30 years of experience across multiple sectors of the pharmaceutical industry, including pharmaceutical commercialization, biotech drug development, managed care distribution, OTC, and retail. He served as VP Business Development for drug development company Phytomedics, Inc., raising over $40 million of private equity and over $50 million in licensing deals, and bringing the lead drug candidate from discovery stage to phase 3 of development. Prior to that, Mr. Pastor was employed by SmithKline Beecham Pharmaceuticals, working in sales, marketing, and business strategies. Mr. Pastor also served as Vice President of Corporate Development for pharmacy benefit management company Prescription Delivery Systems, and acquired by Cigna Health Insurance. He has an MBA from Temple University and a BS Pharmacy from Rutgers University. He also is a board member for Regenerage SAPI DCB, and a clinical company focused on translational therapeutic applications in regenerative and rejuvenative healthcare inventions, and Reanima Project. And he's a member of the Executive Council for World Academy of Medical Science and World Economics Forums for Human Enhancement Council. Everybody, welcome. I'm so happy I got through that, y'all. ira-pastor. Hi, Ira. How are you today?
How you doing? Fine. How are you?
I'm great. I know I messed up some words.
It sounded wonderful.
I tried to make it through. I am so happy to have you here, and thank you again for coming on and talking to my visionary dreamers. And this is a lot to take in. This show, if everybody read the title, is basically this man is working on and has found a cure for a lot of these deadly diseases out here, and working on the projects to bring brain dead people back to life. But first, before we dive into everything, we want to get to know a little bit more about Mr. ira-pastor. First off, just make it clear, are you a pastor? Do you pastor a church?
I get that question a lot. No, unfortunately not. The name was shortened from some long, unpronounceable Russian name back in 18-something when my great-great-grandparents arrived at Ellis Island. But
wow.
But I enjoy the name anyway. It translates to shepherd, and I feel that I'm shepherding.
You're living up to that. Definitely. So tell us about first off, with all that I just said, To my listeners, he is from Philly, the place that I was born and raised. And no, we did not know each other before this time. He just came across the podcast. And yeah, how did you even come across the podcast? And
Yeah, I
what
mean,
made you want to talk to this platform, my listeners?
yeah, well, I mean, you are all about exploring people's potential and their
Mm-hmm.
dreams and transformational ideas.
Mm-hmm.
And I wanted to get a message out about some of what we were doing because while sort of biotech is sort of seen as one of these sort of futuristic things that is
Right.
always 20 to 30 years away.
Mm-hmm.
I like talking about, the sort of the beauty and the possibilities that are really in front of us as we sit here in the year
Right.
2017 to deal with many of the sort of problems
Mm-hmm.
associated with human suffering, human
Right.
disease, and death ultimately. And this is
Mm-hmm.
something that we have been dealing with for thousands of years as people, and we are at a really interesting stage, I believe,
Mm-hmm.
at sort of this intersection of technology and medicine, where the next couple decades coming forth are going to be pretty inspiring and pretty transformative, in my opinion.
Wow.
And just really like being part of sort of unfolding that future for us.
Mm-hmm. So, Ira, now I've read a lot of the stuff that I'm so amazed by you and how far your company has came. What is, kind of paint the picture in short. What did you do as a child? Were you that young boy that collected frogs and kind of dissected them, or like, what was your childhood like? How did you even get into this field?
You know what, I really wasn't as into sort of biology
Mm-hmm.
at a young age. I joke a lot with my children nowadays that I think a lot of it started that I just read entirely too many comic books and saw too many science fiction movies growing up, and
Mm-hmm.
whether it was Spider-Man spinning his web
Mm-hmm.
or stories about people going out into space and going to
Right.
sleep for long periods of time to get out there, or
Mm-hmm.
scuba diving to the bottom of the ocean, breathing liquid
Wow.
oxygen. I
Mm-hmm.
always thought, wow, this is really neat.
Mm-hmm.
Some of those things that I just mentioned, here we are in 2017, and they're
Yes.
all things that are coming to fruition. I mean, we have labs that are learning to spin spider silk to make
Mm.
ultra strong fibers. We
Wow.
have here in downtown Philly at Temple University, they're trying
Mm.
to develop liquid breathing for premature infants that
Wow.
were born too soon, and it's difficult for them to breathe the air.
Mm-hmm.
So they, obviously we are all in our mothers for 9 months breathing liquid. Um,
Yes.
Trying to figure out how we can help babies that maybe are born 3 months early breathe liquid for those 3 months instead of struggling to breathe the air. So it's all
Right.
this type of stuff that really got me excited about the future. But
Mm-hmm.
ultimately, I grew up in a family that was involved in retail pharmacy
Okay.
here in the Philly area, and
Mm-hmm.
so from a very young age, whether it was vacuuming the floors or cleaning the shelves or whatever,
Mm-hmm.
I was always around my dad in his store
Mm-hmm.
while he was doing his job as a pharmacist. There's always around medicine and around sort of patients. Um,
Right.
and that really gave me my nudge that, hey, there's something here for me in the world of um, curing or treating people
Right.
diseases.
Right. Now, because you have such a strong background in pharmaceutical, and because you're from Philly, it's just explains why you're such a hustler. Because we're known as being hustlers from Philly. We wind up doing so many different things, and you have such a wide range, your resume, your portfolio, and at what point, because you were dealing with a lot of pharmaceutical products, a lot of medicine, and I call them Band-Aids. How did you transfer over, or, if you could paint the picture, at what point and how did you feel to make that transformation and try to get into a natural cure for the
Sure.
diseases instead of
Great.
medicating it,
Great question. Great
Mm-hmm.
question. So, I started off as, I went after, I graduated high school. I went to college at Rutgers and got my degree in pharmacy
Mm-hmm.
to sort of follow in my father's footsteps. And at the time, and I think they still do,
Mm-hmm.
they still teach pharmacists in school. They give you 2 semesters of medicinal botany.
Mm-hmm.
So even though you're studying, chemicals and pharmacology and other sciences of this nature, they teach you about plants and
Okay.
natural products from, primarily bacteria and fungi and things like that. Because
Mm-hmm.
I like to point out that even in the year 2017, people have to remember that a large number of all the drugs that we still take today
Mm-hmm.
got their start from nature.
Right.
So aspirin,
Mm-hmm.
um, you know, all of the painkiller opiate drugs,
Mm-hmm.
uh, things of this nature, quinine for malaria. These
Mm-hmm.
all come from the plant or fungal natural realm. So I always had an
Okay.
appreciation for um, nature and the natural world. As I
Mm-hmm.
got more into, as I left sort of the retail space and got involved in big pharma,
Mm-hmm.
which was, an exciting place to be. I mean, I learned about sort of the nature of this beast of an industry that generates, quite a lot of money, selling drugs. I
Right.
began to realize that although they were generating as an industry, $1 trillion a year
Mm-hmm.
and spending hundreds of billions of dollars on R&D,
Mm-hmm.
we weren't coming up with anything to cure patients of disease. We
Okay.
were doing a very good job of creating treatments for
Mm-hmm.
disease. So, you have some pain from your arthritis. We have things to stop that pain. But to cure you of your arthritis is a different thing. We have no answer
Right.
for
Getting
that.
to the root.
And we can go down the line on those types of diseases. And
Yeah, yeah.
so, you know, after a while, I mean, there's people in the pharmaceutical industry that love that job. They love
Mm-hmm.
selling the next thing that comes out of the lab, and they don't. It's not really. But I was different. My mind worked a little differently. That after a while, I got bored of
Right.
that. That was
Mm-hmm.
not in my heart as where I wanted to be forever. I said, okay. So at that point, I left big pharma and I got involved in, and this is where I capitalized a bit. This is before the current company on
Okay.
natural products. And I got involved in this company you mentioned called Phytomedics, which was much
Mm-hmm.
more focused on plants and the botanical
Mm-hmm.
world. And basically going back to nature, as we like to say, and developing natural therapies as opposed to synthesized chemical ones. And that
Right.
was very exciting because I got my taste for how the process works.
Mm-hmm.
In that case, you're not in a lab somewhere cooking something up. You're basically, aside from developing your product, you're going to farms, you're going to forests, you're
Mm.
learning. I traveled around the world. I went to China and I learned from traditional medical healers, or what some group of people was using for thousands of years up in the mountains and so forth.
Yeah.
So I got my fill for sort of the ethno-botanical side of the world and how much there was still to learn out there.
Mm-hmm.
Um, and that really transitioned into what I'm doing now.
Okay.
Because as wonderful as the plant kingdom is, and I love plants and I enjoy gardening and being outside, there are many
Mm-hmm.
other species that are equally exciting.
Yeah. Tell us
And
about that part. As
okay.
far as I was reading as far as how different animals have the ability to kind of repair their own eyes, part of their brains, their limbs, and things of that nature. Like, tell us, like,
Exactly.
what animals and what parts can they repair?
Okay.
You
And
know.
this is a fascinating part of the story, and a lot that I
Mhm.
spent the last several years learning about myself. Not being an animal physiologist, but um, suffice it to say, although we as humans think of ourselves, as the top of this major food chain or on this planet, from a health perspective, we
Mhm.
are extremely weak compared to many of the organisms that are out there.
Right.
As many in the audience undoubtedly will be aware, species like amphibians,
Mhm.
salamanders, newts, and so forth can
Mhm.
regenerate and replace lost or damaged organs that are perfectly identical to the ones prior.
Wow.
This includes spinal cord. This includes arms and legs,
Mhm.
eyeballs, large parts
Mm.
of the heart, and even large parts of the brain. Throughout a
Mm.
lifetime, if they lose it from being attacked by a predator, they will
Mhm.
grow back.
Mm.
What is equally interesting, and this is less well known, is that
Mhm.
many of these same species have fascinating capabilities to reverse genetic damage when it happens.
Yeah, I was looking
So,
at
as an
that.
example, cancer.
Mhm.
Cancer is something that all species on this planet get. Humans get cancer, dogs, cats, frogs, snakes, fish,
Wow, I
trees.
didn't even know that.
Everything on this planet will get cancer at some point. Yet it's
Mhm.
the lower organisms, the one that can regenerate, that don't die from cancer like we do. They
Mm.
basically like to take cancer and turn it back into the normal healthy tissue that it used to be.
Mhm.
These are some fascinating examples. Now you have other parts of this uh, spectrum. There
Mhm.
are organisms on this planet that don't age. There
Mm.
are some organisms, like a certain jellyfish, that age backwards. And
Mm.
then there are a handful of organisms that technically die and come back to life. Um,
Wow. What
so
organisms are they?
they are primarily, and that's a nice little side bit, they are
Mhm.
primarily what are known as um, they're in a class called the polyextremophiles. These are
Okay.
these interesting forms of bacteria that live in nuclear waste.
Mm.
And they
Mhm.
swim around very happily.
Mhm.
In a nuclear reactor, they find these weird bacteria that live, and they're like, well, how do they live in
That's
nuclear
that's
radiation that would
crazy.
destroy us? Yeah. And it turns out they have this fascinating DNA repair capability that they just they'll die and then they come back to life. And it's just
Mm.
so
Wow.
here is a nice spread of uh, nature that
Mhm.
really makes us as humans look kind of weak. Because
Yes.
if any of this stuff happens to us,
Mhm.
we don't get the limb back, we don't get the eyeball back, we don't get the brain back.
Yes.
Um, we have some minor regenerative capability, obviously, in our skin when we get cut. We
Mhm.
have a good wound healing response in that sense. But when it comes to the real critical stuff that is behind all the chronic diseases,
Mhm.
we're really batting zero. And so it's this that we've been very interested in studying. How can we learn from nature, learn from these organisms, and develop interventions for humans
Mhm.
based on what we learn? And this has been the focus of the company since its inception.
So when
Uh,
did the company start for the listeners? When did you start this journey?
We started back in 2008, and
Mhm.
originally we were um, we were doing some initial research down at University of South Florida on the Tampa campus, but we spun
Mhm.
out of there and formed our own laboratories in 2011 and have been freestanding with our own labs, headquarters
Mhm.
here in Philadelphia, and we have partnerships in various countries around the world where we're beginning to explore, beyond the animal models,
Right.
And slowly but surely transition into human studies for various forms of disease.
Right.
But at the end of the day, when people talk about the market and so forth, about what we're really involved in here,
Mm-hmm.
when it comes to we spend now. I mean, it's a sickening number, but around the world now we spend something like $7 trillion on healthcare. About half of
Mm.
it comes from here in the United States. About
Right.
7 trillion. And that's a
That's a
big
lot.
number. It's bigger than
Wow.
oil, natural gas, mine. It's a
Yes.
ridiculous number. And the
Mm.
majority of it, when you put aside sort of infections, the
Mm-hmm.
majority of all of it trickles down to diseases that either have cellular degeneration, so
Mm-hmm.
Alzheimer's, Parkinson's, diabetes, heart
Mm-hmm.
failure, or damage, so your cancer, your autoimmune diseases, your inflammation and pain. And
Yeah.
so we have a wide range of possibilities to address here, and we're a small company, but nonetheless,
Mm-hmm.
we realize the potential of a platform of this nature and why we're so excited and passionate about what we're doing, and why I'm
Right.
much more passionate now than how I was the last 30 years prior when I was just doing the old thing.
Yeah, you're living out your passion. I mean,
Yeah,
and then you're watching it
right.
evolve and just come to life little by little. So I I was reading that you're focused a lot on the kidneys. Why the kidneys? Instead of why that part of the body?
Great question. Um,
Mm-hmm.
the If you look at the list of
Mm-hmm.
all, uh, it's a hard, it's a sad number. But if you look
Mm-hmm.
at the list of the people that wait on organ transplant lists nowadays,
Right.
there are millions that die just waiting.
Mm-hmm.
Um, and obviously at the top of that list are the big things. So at the
Mm-hmm.
top is the heart. Underneath that is the brain, and then you have the pancreas, and so, and
Mm-hmm.
down at the bottom you have the kidneys. And now the
Right.
kidneys, people say, okay, well, why are you doing this? We have
Mm-hmm.
two kidneys, and I
Right.
say, well, this is true, but um, kidney disease represents literally hundreds of small, what are called orphan diseases in our industry. So there are a
Mm-hmm.
lot of diseases that make up kidney disease in general, and all
Mm-hmm.
of them lead to kidney failure. And there's only two options for us nowadays when we have kidney problems. We
Mm-hmm.
can go on dialysis the rest of our lives, or we can have a kidney transplant. Neither
Right.
of those gives a
Or
very
long
good
term.
quality of life.
Right.
And so what
Right.
we're looking to do, and this is, not just, obviously it's a big market, it's a $60 billion market annually, but the more importantly is the fact that because kidney diseases are these smaller orphan conditions, they
Mm-hmm.
offer what are called fast tracking approval in the United States. So the
Mm.
FDA is willing to look at them in a much quicker fashion than some of the heart
Right.
or the brain. So
Mm-hmm.
we look at it as a way to speed up the clinical development and get the proof of, say, kidney regeneration to
Mm-hmm.
market faster. And this is very important because the smart people in the kidney space will tell you that you don't need a new kidney until you lose a substantial amount of the sick ones.
Right.
And we say, fine, this is great because if our technology can regenerate and repair the one that you are losing, you're never
Mm-hmm.
going to have to go down those pathways.
Exactly.
So if you lose 30% of your kidney function and we rebuild it and we give you 100% back, that's a kidney
Mm.
transplant or a dialysis patient that never becomes one. And
Wow.
so, yes, it's hard to juggle whether a kidney is more important than a pancreas or a liver and so forth. But at the end of the day, it just offers a very clear
Right.
fast path for us to
That
help patients.
that was, I mean, that's a definite smart. That was a smart move because as I'm listening to you, like you said, we have two, so it's like if you mess up, then at least you still have one. So definitely, that is great. So have you? I was reading or maybe even watched one of the videos, and it was talking about you going to start testing people that are brain dead and working on bringing them back. Tell us about that.
Yeah, that
What
that
is that?
project is ongoing. It
Mm-hmm.
needless to say, um, it got with today's culture with all the um, zombie Hollywood thing,
Mm-hmm.
sort of went in a different direction than we expected. But let me give you the less sexy background to what it's all
Okay,
about.
good.
Um, in the uh, United States and
Mm-hmm.
in the rest of the world, or in many other countries, there is an area of research that has
Mm-hmm.
been going on since the 1970s, known as living cadaver research.
Mm-hmm.
Basically, what this um, is patient. Some people um, at time of their death donate
Mm-hmm.
their bodies to medicine.
Right.
It happens.
Mm-hmm.
Um, and living cadaver research, the study of various medical techniques, whether they're surgical or devices or drugs, has been conducted on patients of this nature for
Mm-hmm.
decades now, completely legal, completely
Mm-hmm.
ethical manner.
Right.
What we got to thinking, and this was, it wasn't just the fact that this form of research existed. There were other things that
Mm-hmm.
were happening at the same time. You had, and you probably remember, do you remember the Jahai McMath and the Bobby
Mm-hmm.
Christina Brown
Yes.
brain death cases, which
Yes.
were
Mm-hmm.
publicized, substantially in the recent years, and these brought the topic of brain death back to the public fore. On
Mm-hmm.
top of this, us being a regenerative medicine company that is focused on the brain for many other reasons, so Alzheimer's and Parkinson's and spinal cord injuries and things of this nature, we
Mm-hmm.
put it all together. We said, why can't we, utilizing this research system, begin not to look at, using a living cadaver for other purposes, but look at it for
Mm-hmm.
regeneration of nerves and other tissues in the central nervous system. And
Right.
so we're not bringing someone back from the abyss tomorrow. But
Mm-hmm.
um, this is an area that has been defined since 1968 as
Mm-hmm.
irreversible.
Wow.
And we sit here, and the last time I looked, it's the year 2017. So it's
Mm-hmm.
50 years later than when
Yeah.
we defined what brain death was, which is the primary cause or the primary definition of death
Mm-hmm.
around the world. So yes, it is a very important project. It is ongoing. We think it is completely useful, and it's going to lead not just to the eventual um, reanimation, rejuvenation of a human down the line, but
Mm-hmm.
along the way, you have all of the disorders of consciousness,
Right.
comas, and traumatic brain injury, and people that go into persistent vegetative state, like Terry Schiavo.
Mm-hmm.
You have all of these conditions that medical research doesn't go after because it's not, in quotes, profitable.
Right.
um, that we feel are complete. It's because look, 1/3 of us die every day on this planet because our brain dies
Right.
from some type of trauma.
Mm-hmm.
So it's strange that we focus no research resources on this. So
Mm-hmm.
yes, this is the short story is yes, this is a project that is of importance. It's ongoing, and
Mm-hmm.
while it might not be as sexy as Alzheimer's or cancer or some other research
Right.
areas, it is in 2017 with the technologies at our disposal. We feel it is completely necessary and vital to the big picture.
Right, right. So, Ira, I have this question. Now, they talk about cloning and things of that nature, and I know you're talking about pretty much reversing everything. Like,
Mm-hmm.
is there really cloning going on? I mean, I know it kind of has to do with your project, but I just need to know this, because if you're talking about, limbs growing back on animals and things of that nature, how is your project, how can that be affiliated with maybe, I think it was like you know how when they impregnate a lady,
Mm-hmm.
yeah, you get what I'm saying. I probably can't explain it
No,
exactly, but
you're explaining it perfectly, and we're not we're not involved in cloning, but I will explain the differences and how basically the historical cloning research gave us the idea. I mean, it's opposite of what we do, but
right.
there is historic precedent. So I'll
Mm-hmm.
go back. I'm a big fan of sort of medical history and
Mm-hmm.
what has happened in the past. But if you go back to the 1950s,
Mm-hmm.
um, the first clone, I mean, a lot of people think about cloning in sheep
Right.
in the 1990s, but the original cloning experiments were in frogs back in the
Mm-hmm.
1950s. And cloning
Mm.
is very simple. If you think of the egg, normally if you think of the normal event, so you take an egg and a sperm goes inside of it and a baby, and that's how we
Mm-hmm.
make a baby nowadays.
Right.
Cloning is in
I hope.
essence taking the same egg, but instead of
Mm-hmm.
taking a sperm cell, one would take a cell from any other part of the body
Mm-hmm.
and insert the nucleus of that cell, where all the DNA is, into that egg.
Mm-hmm. Wow.
Cloning is a very dirty, inefficient process.
Mm-hmm.
I say that because, when it's done, um, you don't get a perfect baby all the time.
Right.
Whether that's a baby frog or a baby mouse or a baby rabbit, whatever they're doing, is
Mm-hmm.
a very um, imperfect thing. So
Right.
we are not very interested in cloning. But what
That's
we
good.
are interested in, and this is
Mm-hmm.
the basis for our work,
Mm-hmm.
is what's going on inside the egg. Because
Right.
this, and I know, stem cells have gotten a lot
Yes.
of press over the last 10, 20 years, but the
Mm-hmm.
real master cell is the egg cell. And all the ladies listening should stand up
Mm-hmm.
and take a bow, because you're responsible for this. Men, we don't really do
Yes.
much.
Yes.
It is,
We notice. We
yes.
notice.
So,
Thank you for
but
confirming it for us.
it is what is inside the eggs that all animals, including female humans, produce, that is responsible for why all of our babies are born age 0,
Mm-hmm.
why they come out for the most part with, 2 arms, 2 legs, a properly,
Mm-hmm.
structured child.
Mm-hmm.
And no baby is ever born with the diseases of old age. So, you will never get a baby that has Alzheimer's disease or,
Mm-hmm.
Parkinson's or, name the list of the diseases of aging.
Right. Right.
The egg cell, which all the females make, is responsible for this. So we're not interested in eggs for cloning, but what we are
Mm-hmm.
interested in is in taking and studying the proteins and the peptides and all of the natural factors that women place into those eggs when they produce them.
Right.
And that is the basis for our research. So in many ways,
Mm.
we are taking that and doing almost, reversing cloning into humans. So basically using these natural peptides and substances as the biopharmaceutical product, which then we can rejuvenate different tissues in your body with. So
Okay.
sorry for the long
No, no, no,
roundabout
no. No, that was great,
but
because it's like, this is the show for everyday folk. That's normal folk. So I just wanted it to be broken down as clear as possible. So definitely, I really appreciate you breaking everything down so we can understand it better. And I get where you're coming from, because when you were saying, as far as I was reading, when you were saying that the cell therapies are falling short, the stem cell therapies. are falling short versus your method. I think that what you just said, it kind of explains it a little bit better. So
Yeah.
how do you separate, because you were talking about, and I don't know if it's an article I read of yours about the bad tissue and kind of separating the bad tissue and I don't know, fixing it, and then how does that process look?
It's another great question. So when we uh, when we're sick in some
Mm-hmm.
fashion,
Mm-hmm.
whatever the disease is, as mentioned before in that kidney example when we were talking, when you
Right.
have a kidney disease, not every part of your kidney is damaged.
Right.
There is still healthy tissue there.
Mm-hmm.
There is dying and diseased tissue there. Healthy cells and sick cells have very different, let's just say, we call it different fingerprints. And now, not to get um, too scientific, but
Mm-hmm.
they act very differently. They
Right.
shape differently. They have different chemicals that are being secreted from them. They have actually very different electrical properties because even though we're biological organisms, we do also have natural electrical currents flowing through our bodies. So
Right. We
those
are
cells are very
electricity.
different. And
Mm-hmm.
so what we are doing, we are targeting those tissues with our material. And what we're trying to do is basically mimic what we see in, say the case of that salamander whose
Right.
tail is bitten
Okay.
off. So now
Okay.
you have healthy tissue and a lot of dead and dying tissue because the snake or whatever came along and bit its tail off. We
Mm-hmm.
are now providing back to that dead and dying tissue our material, our drug materials, our proteins that basically tell the remaining tissue
Mm-hmm.
what to become. And this is,
Mm.
as you just mentioned with the stem cells, this has been a missing part of the puzzle because it's
Okay.
not enough just to say, hey, here's some new cells that we're going to put here. That's not going to form a new tail, a new heart, a new brain. No. You need to
Mm-hmm.
have the signals that say, hey, a spinal cord goes here, a heart goes here, an eyeball goes here. It
Mm.
has to be the right size, it has to be the right shape. So,
Mm.
unlike stem cells, which we think of more as Legos and trying to put together things by dumping a lot of cells in.
Mm-hmm.
Those cells don't get the message by themselves, and this is what the salamander and all these other organisms do.
Mm-hmm.
Um, they not only recruit new cells, but they, with the proper signals, tell those cells what to become and when to stop growing. You
Wow.
do not want, I use the analogy, you don't want the heart forming in your foot. you, you you don't want it
Right.
to be the size of a watermelon. There's
Mm-hmm.
and this has sort of been the missing piece.
Mm-hmm.
And this is sort of the nature of how our material works. Not only does it supply the signals for what this tissue needs to become, but it also takes into account the nature of the healthy and the diseased tissue, so it knows it more appropriately can enter those dying, disease, damaged tissues and turn them back into the healthier tissue that we want and start the development process or the healing process over.
Oh, okay.
Um, and once again, it's based on everything that we see and it's been studied. It's not just all our work, but
Right.
a lot of the study on regeneration of this nature goes back, the 1920s and the 1930s. We're just now
Mm-hmm.
sort of reconnecting it with modern tools.
Right. So, you're partnered up with a couple of companies,
Mm-hmm.
and those companies are into the the health and wellness and the beauty care, far as the hair loss. Well, actually, no, your company I was reading deals with the hair loss and skin wrinkling. How, oh, and the shrinking of tumors. Like, can you talk to us about that? Like, what part is it? The BQA? What
Mm-hmm.
is that? The bio,
Okay, so
what is it?
that, BQA, that's sort of our code for one of our lead candidates that we're developing. So
Mm-hmm.
that is a mixture of proteins and peptides and other biomolecules that we have isolated based on what we were talking about before, based on our study of the egg dynamic, the
Mm-hmm.
reprogramming and the rewinding of the cellular history, so we can start over again. And
Right.
yes, that is um, we are using that material we're developing on the cancer side as a new drug substance
Mm-hmm.
for cancer, but similar material for the non-prescription cosmetic um, wrinkling and things of this nature,
Mm-hmm.
because just in the nature of the business we're in, we have
Right.
both, we have a huge consumer products interest out there as well. So it's just
Mm-hmm.
the nature of the company to go in both
Mm-hmm.
directions. But yes, as pointed before, um, cancer is something that's very near and dear to us as a
Mm-hmm.
company, and just from personal history. Here you have this area, and it's still in major parts of the world the leading
Right.
killer of us.
Mm-hmm.
Every year we have 14 million new cases diagnosed of cancer, and 8 million die.
Yeah.
Um, and this is, although the war on cancer has been going on for many decades now, it is still very what we call kill focused. I know
Mm-hmm.
this is kind of a weird concept, but everything, whether it's the old methods of chemotherapy or some of the newer things that you see in the press regarding immunotherapies, it's all
Mm-hmm.
based on a kill response.
Right.
However, however, um, every organism that I told you about before that gets cancer and gets rid of cancer
Right.
doesn't do it by killing. It does it by changing. It does it by
Mm.
taking that tumor in the
Mm-hmm.
breast and turning it back into normal breast tissue, or turning it
Right.
back into normal brain tissue.
Mm-hmm.
This, we believe, is a much not just more natural approach, but it is a much more realistic approach
Right. And
to
safer,
the
it
current
seems like.
system.
Right.
Yes.
Yeah.
Because as much as we've been going at cancer for decades now, we're on cancer too now. But as much as we've been going after it, I think in many ways we've been missing the big picture that you need. Cancer is something that, as you say, has been evolving for
Mm-hmm.
over 1 billion years. It's nothing new to
Right.
us.
Yes.
Well before we were here,
Mm-hmm.
monkeys got cancer. I mean,
Mm.
before the monkeys were here, snakes got cancer. So it goes back a long history. And
Mm-hmm.
it's rethinking how we're doing this, as opposed to just let's find better ways to kill. We think, okay,
Mm-hmm.
cancer is going to get out, but no other disease would we ever think. If I have Alzheimer's disease, I'm not going to chop a piece of my brain out. It's
Exactly.
not it's
Right.
not it's not the method. And just a side note, another little sort of shout out to Philly.
Mm-hmm.
Back in the 1970s, here at University of Pennsylvania, it was
Mm-hmm.
first discovered in well in rodent models, but nonetheless, it was the first example of this here right down the street at UPenn,
Mm-hmm.
how, once again, the ability of the egg and the embryo to turn back time in those cancer cells and normalize them was first
Mm-hmm.
discovered. And, it's the lady's name, I think she's still alive. Her name was Beatrice Mintz. I think she's at
Mm-hmm.
Fox Chase now or something.
Right.
But it was the first beautiful case of how you could take an embryo. Now, this is not a human embryo, but it was
Right.
you took an embryo, you
Mm-hmm.
stuffed in cancer cells, and then you had a baby born. You had a baby rabbit or a guinea pig or what have you, and
Mm-hmm.
the baby did not have cancer. And it was the
Mm.
first discovery that, wow, this concept of regenerative reprogramming of cancer was
Mm-hmm.
real. And then
Right.
what happened? It was forgotten for the it was forgotten for the next 50 years. So,
Yeah, because they wanted to probably still
it-
stuff the medicine. My
right.
father died of cancer, and I watched him like pretty much disappear. It's like it's something how it just eats you alive. He's like 78 pounds, when he died.
Yeah,
And
the same thing happened to my father, and it was
wow.
it was horrific.
Hmm.
So we are very focused on looking for alternatives that make more sense from
Right.
not just a safety perspective, but from a
Hmm.
nature perspective. From hey, there is much history here. There's billions of years of history here
Hmm.
behind what cancer is, and we
Hmm.
need to approach it differently.
Is that
Um,
what fueled it for you? Is that what because of your father, is that
Oh,
what made
absolutely. I
you?
mean, that
Okay.
was, and I'm a big proponent of a lot of what's going on in the world nowadays with, experimental access.
Hmm.
I
Hmm.
believe that, right today, we have, those cancer numbers, and one of the sad things is that it's estimated that less than 5% of all cancer patients ever seek out clinical studies. Okay.
Right.
At the end of the road, they never even look for them. And my
Hmm.
father, it was a kind of interesting story. My father, this was in, I think, the early 80s, got
Hmm.
involved in one of the first so-called compassionate use studies in cancer. He had prostate cancer.
Mm.
And it extended his. I mean, he got a good 6 more years,
Oh, wow.
and then unfortunately, it spread to his spine, and that was
Hmm.
then it was the end. But
Mm.
I bring that up. Sorry, as sort of a side
Oh, no, that's
story.
that's definitely well in the realm of what we're talking about
Yeah,
because,
I just bring that up to get the message out to everybody that,
right.
God forbid, you're dealing with a degenerative disease or a sort of a no option case. Get out there and seek out clinical studies. There's
So you
many
think
good
they're safe?
databases.
They're pretty good then. I
If I
mean, you,
Safety is one of those things that is um, you don't know safety on a group base. You know safety on an individual basis. And
right.
so I always say, look, if I have pancreatic cancer, later stage pancreatic cancer, I don't care too much about, certain low level side effects that were found in,
Hmm.
an early clinical study. I want to try the drug.
Exactly.
Um,
If you have nothing
and
else to lose, they couldn't do anything else for you. Why not? Yeah,
yeah. And
I
and
get
of
it.
course it's always up to, the discussion and talking with the clinicians, but I
Hmm.
really just want to get that concept out there that there are hundreds of clinical studies going on right now in the
Hmm.
United States alone and many overseas for something like cancer.
Hmm.
If you come to the end of the road with your traditional clinician, seek out these options because a
Yeah,
very
because what
small
do you
percent of
have to
patients ever
lose?
do.
So how can people, where is it that, because now everybody, I'm definitely going to put all of Ira's information on the blog, and I'll have it all available for you guys on tomorrow to view and to read over. But for right now, where can people look for clinical studies if they feel like they're at the end of the road with their traditional medicines?
There's a wonderful website. It's run by the National Institutes of Health. It's called clinicaltrials.gov, run by
Mm-hmm.
I have to say, it's probably one of the really good resources of our federal
Mm-hmm.
government. You can, go on there. It's called clinicaltrials.gov, and,
I'll put
you
it in the
just
description
yeah, you
on the
put
blog.
in,
Mm-hmm.
anything from Alzheimer's to cancer to diabetes, and what will come up is a list, not just of U.S. programs, but programs
Mm-hmm.
everywhere. So
Wow.
if there's something going on in Greece or
Mm.
Thailand, it'll tell you
Mm-hmm.
about it. And they say they're not going to be all for you, but it's a great information resource that then you can talk to your primary clinician, your loved ones, and get thoughts and feedback. And it's just, once again, I just really want to put it out there because it's something that
Yeah, that's important. That is
it's
so,
important
so
people know about.
important. Yeah,
Yeah.
yeah. So thank you for that because a lot of people, like you said, they just go get their prescription. They don't even, some people don't even read about the side effects, and it's just, okay, the doctor gave it to me and that's just that. And they don't know if they individually will agree with that medicine. And, so again, just the fact that there are options out there, and this can give people hope that maybe it's not the end of the road if the doctor says, oh, okay, you have 6 months on this type of medication, but there's nothing else we could do for you. Now, at least my listeners can spread the word. I'll put the link in and share that. So that's great. So I know we wanted down on time. I just want you to touch on far as your partners and how is that involved with your company? What is it? Reanima and Regenerage.
So Regenerage is one example of a relationship that we formed, and we have several of them. Basically, the story is, we are a United States company. We are focused on the United States market, but the United States regulatory system for everything we're doing is pretty straightforward, and we're not going to be on market here in the United States for the next 3-5 years. However, there is a large world out there, and once again, the smart people will tell you that is from a business perspective that although the United States is a major part of the market, around 40% nowadays, unless you're looking at the rest of the world in the next 10 to 20 years, you're going to miss the boat. And so we are entering relationships where different clinics and companies are licensing some of our technologies to move into the clinical regulatory situation faster. And if we can get and save lives in China or Turkey or Costa Rica a few years earlier, hey, that's all part of the big.
That's the data. That's the data you need to bring it back.
So, Regenerate is one example of that. And, while this whole area has been, it's, sort of termed medical tourism or medical travel nowadays, where people have been going abroad to get cheaper sort of alternatives, things like, dental care and different types of elective surgeries. What you're seeing now is also pharmaceutical companies, and there was a situation just a few months ago where Merck, which is one of the largest drug companies in the world, recently partnered with the government of China to allow compassionate access, once again, to one of their cancer drugs. You go to China, and Merck, it's not just a niche thing anymore. So it's really going to be changing a lot. The old structures of the past are really going to be blurred a lot in the next 10, 20 years about, where therapies are going to be consummated and so forth. So it's a big world out there. So
So now when you, far as the clinical studies, I'm sure the listeners would like to know, when you talk about getting help abroad, and if they take a part in the clinical study, is the travel paid for, or do people have to pay for their own travel, or is it like it depends on the company that's doing the clinical study?
It depends on the company that's doing it, but we can, because we're not a clinical company today in the U.S., but we can definitely recommend several different partners of ours today, and they would be open to discuss those issues. But for the most part, the sort of the nature of the traveling sort of component of the procedural medical travel business is pretty well structured now, especially with the amount of, I think they estimate something like 11 million Americans are going abroad nowadays for
treatments and stuff.
Some treatments. So there is this and we're not a travel agency, but there's a
Yeah, but at
whole
least.
sort of travel agency system around medical tourism that has developed where, these agencies will help you get the flight and they'll get the ride to a hospital and they'll set up the hotel. And so, there's that. That's a whole, that's a whole
Right,
other
it's a
thing
whole another monster,
about these
right?
structures. Yeah.
All right, so your company though, you offer clinical studies right now, or are you you're still in the stages of, with animals, or when will it be open, if not now, to
Yeah, our
humans to
U.S.
study?
program in terms of clinical studies is not going to be online for the next, probably not for about 3 years. But we do have,
Hmm.
as I mentioned, we do have some partner organizations
Yeah, as far as
overseas
your
that
partners.
work with us. So
Hmm. You could
they're not,
recommend your
they're not our
partners.
clinical units, but we can definitely recommend and introduce to
Hmm.
hospitals that are working and have
Okay.
licensed part of our technology set, if of interest.
Okay. Okay. So I will tell the listeners where they can find you, and connect. I know we have this. You have the site BioKirk. Is that .com? Tell
Hmm.
them where they can connect you or reach. Anybody that wants to get in touch with you, as far as whatever.
Yeah, I mean that's you can come to the website and learn a lot
Hmm.
about our programs and our ongoing research. Yeah, I'm very open to talk to everybody about what we're doing.
Hmm.
So I mean, my
Hmm.
email is just pastor@bioquark.com, and
Hmm.
anyone can reach out to me.
Hmm.
As the CEO of this company, as I mentioned, I run the company. I have a passion for everything we're doing, and I'd be glad to help anybody sort of exploring this whole area learn more.
Hmm. Hmm. Great, great. Any other last words you want to leave us with when it comes to, as far as the pharmaceutical world versus your new world?
I'm glad you brought that up.
Hmm.
Um, I really see a new industry developing that is going to be based on cure as opposed to
Hmm.
treatment. They're really two very different things, and I don't think the pharmaceutical industry as it exists today is going to be what we're going to be seeing 10, 20 years down the road. That being
Hmm.
said, just as a very positive statement, the future is very bright in
Right.
regard to the coming era of how these discoveries on health and wellness are going to impact our lives. And I know, too much nowadays is bombarding us with, in the social media with
Hmm.
wars and terrorism and so forth. But there really is a very promising and bright future as
Right.
far as human health and wellness is concerned. And I just want to, as I said at the beginning, while this business is normally seen as very sort of technical and boring, it is very, when you really get
Oh, it's
into it, it can be
exciting to
quite
me.
exciting. Yeah, it can be quite
People think I'm
exciting.
weird anyway. Wow. So I just definitely want to thank you. I mean, I'm just excited for you and your company, and definitely going to be following you. And definitely we got to, touch bases again and have you back on the show, a year from now, just to kind of update the listeners as to, or
Absolutely.
either whenever you have some new breaking thing that comes through, I want you to come back and share with the listeners anything new that you have to share. We would definitely appreciate it. And
Absolutely.
yeah, I'm just so glad. I'm glad that you reached out. This is an awesome, awesome day in history. We're learning something new, and that's what the show is all about. So I just want to tell everybody thank you again to ira-pastor for coming on. And this is Adionne, and you're listening to Chronicles of Living podcast show, the show for everyday people doing everyday things, living everyday life. And I am your dream pusher, saving you from yourself, saving you from drowning in the world. Get out your own way, y'all. Do the damn thing. I love you guys. Treat yourself right. Take care of yourself, and definitely look out for BioQuirk. Until, what is the day? Sunday. Until tomorrow, 7 p.m. Peace.
Thank you for listening to Chronicles of Living, where we talk to everyday people about everyday things in the past, present, and future. And if you are pursuing your dreams, I'm proud of you. Because the best part of life is when you decide to live. To keep up with us, please visit chronicles-of-livin-podcast. Until next time, this is Adionne, your dream pusher. I love you guys.